Yeah, I need that later. Good morning. How y'all doing? Nobody left. All right, good. Well, thanks, Paul, for not slaughtering the name of my university. As Paul mentioned, I'm originally from Venezuela. I have friends who always ask me, hey, Jorge, so I hear that Venezuelan women always win the Miss Universe. I mean, they're the most beautiful women in the universe. Like, I don't know about the universe, maybe this solar system or the galaxy. Anyway, bad joke, check. I have a friend who recently talked to me about the TV reality show called The Bachelor. And apparently, the guy was a Venezuelan guy. So they're starting saying that most handsome men come from Venezuela as well. So I'm like, all right. Every morning in the mirror, I'm like, yeah, I like that. Anyway, today I want to talk to you about the Aquaveo WMS. It's I say it's a strong yet flexible hydraulic software. We'll get to that in a minute. Today's agenda, well, we're going to do a hypothetical case study where we're going to use WMS built-in data acquisition tools to delineate a watershed. Then we're going to talk about problems with the data sets, and we're going to talk about other sources where you can acquire these data sets. Finally, we're going to do a little comparison. All right, for this hypothetical case study, I chose this location. Again, this is completely hypothetical. We're right here in the theater, in the amphitheater. And right here on SH6, there is a big creek. There is a culvert right there. Now, the district needs to determine if this culvert is still at capacity. Based on historical imagery, you can see here, in the last 20 years, this area has developed incredibly. I would say that was probably about 10, 20% impervious cover, and now it's close to 100%. So this is the location of our culvert. It's right there, over there. This is what Aquaveo WMS looks like. If any of you have used GIS software, you'll see that it's very similar. The way you acquire or you add the data to Aquaveo, you use this little button right here. You do the pull down button, and you're going to get this menu. You select Get the Data from the Maps. It's going to bring you to a Bing's map. What you do here, you can select either latitude or longitude to locate your project, or you can just simply use, scroll and drag and zoom in, out, etc. Once you have this, your location project selected, you click OK, and it's going to bring you to this. Now, with Aquaveo, you can add straight from the program several layers, including DEMs, data elevation models. You can do a type of culvert. You can use type of soil. But for this exercise, we're going to select the United States data elevation 10-meter resolution. You click OK. The program is going to ask you to save it, give it a name, create the file, yes. And the standard cell size for this one is 10 meters. Oh, wow. All right, once you add the data, you can see you receive a lot of type of contours. Anybody who has worked with hydrology and hydraulics, very familiar with this. The next step will be to locate your project. We cannot really see where the culvert is in here. So what we're going to do is we're going to add online maps. It's going to give you the aerial view maps. We select this one. Bam! Our project is located right there, over there. And by this moment, I realize I have done a mistake that I haven't saved the project just yet. So always remember, especially with this software, not trying to talk bad about any software specific, but it has happened to me in the past that I've worked for hours. Next thing I know, I get the blue screen of death in Windows, and I have to restart everything. So please make sure you save your project. Right there, it has a name now. And the next step is to use the Hydrologic modeling wizard. That is that little button right there. It's going to bring up this menu, And here we're going to select the compute flow, compute the flow directions with Topaz. Topaz is a subroutine that is built into WMS that basically calculates the flow direction based on the data elevation models. Basically, a data elevation model, and I talked about this last year as well. There's like points, X and Y points with elevation. So what Topaz does is in each point, it determines where the water will flow depending on the elevation of the 8 different cells around it. So once you once you select that, this is what it looks like. You will click Compute Topaz, and it will give you a little window that will give you a running time. In this case, the data is so small, it only took 1 second. And it creates this. You cannot really see it here because the aerial view is on, so we can turn it off. And as you can see now, there's some sort of streams that were not there present before. That is the flow accumulation. That is basically what the program tells you the water is flowing through, or it's going to flow towards. Our location is right there. And once you zoom in, this is what it looks like. As you can see, it looks almost like a little creek or a little river that goes under the road, exactly where the culvert is. The next step is to assign an outlet. WMS needs an outlet point to determine, you're going to tell them, I need you to delineate the watershed right here at this point. So on the same Hydrologic wizard tool, you go back and you click on somewhere in here where it says outlet, and it's going to bring you to this. Once you, right there, choose outlet location, and it's going to bring you to this tool right here. You click on create an outlet point, and you go back to where your culvert is. Once again, here's our culvert. You click, and it's going to add an outlet. You can barely see it there. So let's zoom in a little bit. And that's what it looks like. So basically, WMS is going to calculate, or it's going to delineate the watershed at that specific point. Excuse me. And the last step to delineate this watershed is to click on Delineate Watershed. It's going to bring you to this other menu, and obviously you click on Delineate Watershed, and bam, just like magic, it is called the Hydrologic Wizard for a reason. It delineates the watershed for you. Depending on the size of the watershed, it will take a little longer, but if you do it right, it shouldn't take, this whole process shouldn't take you more than 30 minutes. My understanding is that, 20 years ago when I was in high school or whatever, this would take days, possibly a week, depending on the size of your watershed. As you can see, this is really awesome. Okay, I'm turning off the layers here. And it even gives you immediately, you don't even have to do anything. It tells you, hey, by the way, the area is 1.27 square miles. So this is how you delineate a watershed using WMS. Excuse me. Now, the reason why I call this presentation flexible is because sometimes you have problems, or let me rephrase that. It's because you are not married to the built-in tools in WMS to acquire your data. So why or when not to use the built-in web data service on WMS? Whenever you can't, and I know that sounds silly, but that's really what I meant. What does that mean? Well, let's say there is a federal government shutdown, hypothetically. Exactly a year ago, the government was shut down. And about a year and a month ago, I was working on a presentation on GIS where I wanted to present to y'all this stuff here, but I couldn't. Why? Because when I went to the USGS website, it was like, hey, sorry, we are not working right now, come back later. And WMS built-in tool, unfortunately, it's married to certain specific servers. The DEM server comes out of the USGS. So when I try to use when I try to use WMS to pull DEM data, it didn't work. And so that actually was the reason why I'm presenting this today, because I figured out, well, there's got to be a better way than just the government tells you, come back next month, So that's one of the times where you cannot use it. When the WMS internal server is down, WMS uses a server that connects to another server and then pulls data. Well, nothing is perfect. If the WMS server is down, you just won't be able to use this tool. I'm not sure that happens often or ever, but again. Or when you don't have data connection. Let's say you're in the middle of nowhere and there is no AT&T or whatever, and you need to use some data to create a watershed. Well, if you have this data on, let's say, a disk, a USB storage, it's somewhere in an internal server in TextDot, then you will use that data. You wouldn't use WMS because you can't. When you have more accurate or more current data, which, that's pretty self-explanatory, the USGS data can be, depending when it was, acquired, could be really old, could be years old. And if you have a recent survey for a location you are working on, it's recommended that you use the data you have currently. And when the data is corrupted or it cannot be trusted. Well, what do I mean by this? A couple of years ago, I started working on a Presidio project, an international bridge at Presidio. I'm actually still working on that. I think Mike is in the audience somewhere. And I was trying to determine the effects of this bridge, like way up there. And I decided to use Google Earth 3D visualizer to go up there and see what was going on up there. And then I found this. And no, Google has not found a place where the water flows upstream. But as you can see, something really strange happens at the border between the United States and Mexico. It could be a datum problem. It could be, using the United States system versus the rest of the world system, metric system, sorry. And actually this happened to us. We tried to acquire data from USGS to work on the Presidio project, and it was just a little crazy. So we had to go and survey. So in the same, this is my favorite part. For this presentation, I was wondering, I wonder what's going on in the border between Mexico and Texas, like anywhere else. And this is my favorite place, Esperanza in Texas. When you get home today, Google Esperanza, Texas in Google Maps, and you'll find the Rio Grande Canyon. As you can see, I didn't know there was a canyon right there between Mexico and the United States. But this happens for a reason. This is out of our hands. And if WMS is going to pull information from here, the expression trash in, trash out, this is basically it. Any hydraulic engineer here, imagine if you were to cut cross-sections for your HECRAS model. That's going to be awesome. And once again, I have no idea what is this, but apparently it's 1,800 feet tall. Maybe it's a fence of some sort, I don't know. Anyway, so what other sources of data elevation we have available? Well, again, I mentioned the USGS national map because even though WMS pulls information from it, if there is a problem with WMS, you can go directly into the USGS data map and get this information. It's called the national map. There is the address. TNRIS, here specific to Texas, the Texas Natural Resource Information System, TNRIS. You can go to county, cities, or metropolitan authorities website. I want to show you real quick, and I'm not going to get too much into depth into this next steps because my presentation from last year explains this in depth. So if anybody needs this, please let me know. But a quick run on how to obtain the data from TNRIS. This is the TNRIS website. When you click on Maps and Data, download data, it will give you an option to search by quadrant or county. And in this specific case, our project is, I believe, somewhere in here. Anyway, once you find your quadrant, you can download the data by clicking the elevation options you have right here. In this case, I downloaded the ASCII DEM. And the way to add it to, once you downloaded that data, the way to add it to WMS, like manually, you use the same button up there, but instead of clicking the pull down, you actually click the plus sign. And this is what it looks like once it's added. Now, what I want you to know is something. This data set is huge, and I'll show you in a minute. The first thing you do is you have to convert this into terrain data, and you right-click on the actual layer that was just added and convert it to a DEM, and that is what it looks like. It looks more like contours, which was what we had in the previous example. Like I said, this data set is huge. So an important tool to use on WMS is the trimming tool. To do that, you right-click on the layer that was just created, and you go to Tools, Trim, and you use Polygon. And the way I do this, personally, I zoom in, there it is. I zoom into my location, and I basically click on each one of the corners, and I create a little square of the data that I need. My culvert is right there. In the drainage area, I can tell it's going to be something like this in here. So I zoom in to the extent of what I need, and I click on each one of the corners, and I get a smaller, better data set to work with. Following the previous steps I just explained, we come out with another flow accumulation and another drainage area. It's a little bit bigger. It's 1.30 square miles, but that's obvious because it's a different data set, resolutions, whatever happened there. But it's pretty comparable to our previous calculated drainage area. Now, here's what I wanted to show you. That is the size of the data set we just trimmed. That is the size of the original data set. And if you don't trim your data set, you make a mistake or you forget it, you might spend hours, specifically 3 hours and 22 minutes looking at your monitor. And by an hour and a half, you say, no, it's about to finish. Just wait, it's almost finished. 2.5 hours later, it's like, I'm going home. I'll just leave this all night. So please cut trim your data set to the extent of what you need. Now, the last thing I want to talk about real quick, before pouring water over myself, I wanted to show you the City of College Station GIS website. They have a pretty cool, I don't know if anybody from the City of College Station is here, but this is really cool tools you all have. This is the same type of DEM you can download. Obviously, it's a little trimmed to the city limits. And I ran the same process that I just did, the workflow. And I found this, which is really interesting. When I calculated the flow accumulation using the City of College Station data set, now look at that. Our culvert is here. This doesn't look anything with what we previously calculated. So what does this tell you? To me, it tells me, and by the way, that's what the drainage area looks like. It's almost double the size. So when that happens, what do we do? What do I do now? Well, first of all, I strongly advise you that you should do a site visit, visit the site. Once you visit the site, you can actually go and see by yourself what's going on there. Because if we go back real quick in here, it almost looks like this water that accumulated here previously, and there maybe was a culvert down here and connected here. It's somehow been channelized via a ditch or something. Also, the data sets that we previously worked with from USGS and TIMRIS might be so old that it has changed ever since. So this is more current, and I personally, my own personal opinion is I would stick to whatever the localized, in this case the City of College Station, whatever data set they have. But back to this, remember, visit the site, use engineering judgment. As an engineer, it's your responsibility, it's your job to decide, okay, do I go with 1.37 square miles, or do I go all the way with 2.6? What is more conservative? Once again, I would probably go with whatever I acquire from the City of College Station. Do a site visit. Once you do a site visit, again, go look at the site, be there, experience by yourself what's going on, look at the water, where is it going, where is it flowing. Maybe you'll see a culvert that was there years ago, but now it's been, obliterated, cab, or whatever it's called, and then the water is now being rerouted to the other culvert. Contact local personnel. In this case, I will talk to the city of College Station or Brazos County. Are we in Brazos County? Okay, Brazos County. Go to the university, talk to researchers, somebody who is familiar with the site you're trying to work with. And finally, last but not least, visita el sitio, or do a site visit in English. You have no idea how much I'm trying to emphasize. Get out of your butt and go to the site. I mean, you will not be able to see on the computer through the, again, I thought there was a canyon, the Rio Grande Canyon, I thought it was between Mexico and Texas, and that's not true. I went over there, and I'm lying. No, but you know what I mean. Get out and all right? And last thing, if you need to arrange a class for your district, ask the district hydraulic engineer of your district or your training coordinator. Or you could also send an email to the chief hydraulic engineer, Amy Ronfield. She's in the design division in hydraulics. There is her email down there, and her contact information will be in the last slide, just in case you need to annotate it. With that, I've been informed that I need to go to questions and answers. Do you have any questions? Because I might not have any answers.